In this section, I'm going to take a lot of the things that we've been talking about and I'm going to put them all together now so you can see it as a cohesive story. Specifically, we're going to be talking about a cluster. Within the cluster, we have a domain name service, and we're also going to have some reverse proxies in here too in order to allow the service-to-service communication to go. So first, let's say from the internet, a client request comes into the data center where the first thing it hits is a load balancer, which, if you'll recall, is actually an example of a reverse proxy. In this case, I have 3 instances of the website service running. So they each have their own IP address or port, some running on some VMs that are part of this cluster. The load balancer is going to choose one of those instances and send the traffic to it. Let's just say in this case it chose website number 1. Now, website number 1 wants to go and talk to the inventory service. But there's 3 instances of the inventory service. So it needs to know the address of the inventory service, and then it needs to go and talk to one of those. So if this is the first time we're talking to the inventory service, the website is probably going to talk to a domain name service that's also running within the cluster. And the domain name service really has a map or table in it that maps the inventory service. This is the endpoint of the reverse proxy for the inventory service. And for the order service, this is the endpoint of the reverse proxy for the order service, which are these red guys over here that I show inside the cluster. Now, after this website hits the DNS service and it gets the endpoint for the inventory reverse proxy, the website then will go and talk to the reverse proxy service. And it's really kind of a load balancer in this case that's then going to pick one of the instances of the inventory service and direct that request to it. In this case, I have it going to inventory service number 3. So now number 3 goes and does its work, and then it would return back. But I also have a note up here too, and it's a warning note, right? Because you have to remember failure is possible at any time. So while we're talking to inventory service number 3, it could go down. It could have received the request, and then it could have had an unhandled exception. So now the reverse proxy would know, because the orchestrator would tell it, and then any new requests that come into the reverse proxy, the orchestrator, well, it would send it to instance number 1 or instance 2 until instance number 3 is healed and comes back online. So the point I'm trying to make here is that it's impossible to keep endpoints in sync as service instances come and go. It's literally impossible, which is why I put it in bold italics letter. Your client could go and request the endpoint of something, and once you have that endpoint, when you go and talk to it, it may not be there anymore. And things will change, but things are changing dynamically, and it's impossible to keep everything in sync. So client code must be robust against this, and typically that's done with retries. Now, in this example here, if inventory number 3 goes down, it's possible that the reverse proxy could do the retry and make the request to inventory number 2 or number 1. So now the website number 1 isn't doing the retry because the reverse proxy is doing it on your behalf. Right? And that's a nice feature of reverse proxies, to kind of give you that abstraction or isolation so that you don't have to write the code. Whoever wrote this code for the reverse proxy has to deal with these issues, and you, not so much. However, you're probably going to end up having to do retry code anyway for other reasons. For example, a timeout might occur. So you might make a request to the reverse proxy for inventory, and maybe it's just taking longer to respond than you thought. And so you might get a timeout inside your instance, and then you might want to retry because maybe the next time you retry it'll be faster. So you're probably still going to want some retry code, but the reverse proxy can maybe improve the performance because it's only 1 network hop instead of 2. Another thing to be aware of, since failure is always possible, is that while your instance here is talking to the reverse proxy, which is in turn talking to an inventory instance, your instance could go down. Maybe this gets scaled down, or maybe you crash over here. So when inventory 3 returns a result, it's trying to return back to your instance, but your instance went down and is no longer running. Well, in that case, the client all the way back here is going to get the failure because you went down when handling their client request. And so they will actually have to retry from back here to make a request to the load balancer. The load balancer should send it to any instance that's up, and then the whole process will have to start all over again. So the point of all of this is to say that the networking is challenging, and that retry support in these various mechanisms is mandatory. It's really not something that you can just say, well, it works 99% of the time or better, and so I'm just not going to do it all. At all, right? You really want to be resilient to these kinds of failures. You really want to make sure that you have retries in all the various steps of the way. Another thing that I should point out on this slide is that this reverse proxy, the way it looks like right now, is it is a single point of failure. And that's actually true of the DNS server too. If this goes down when any of the websites are trying to query the DNS, if it's down, then certainly it can't talk to any of the other instances. Or if the reverse proxy goes down, then you can't talk to any of the instances. So you want to design the DNS and the reverse proxy to be resilient and not be a single point of failure. For the same reason we have 3 instances of the website, 3 instances of the inventory, 2 instances of the orders, right? So that there is no single point of failure.